I'm the math guy. Duh.
And peace, everybody. It's 8:30 Prep live from the 8:30 Prep studios at 3R Prep. I don't even know why I called it 8:30 Prep, only because we started 8:30. So we're going to be doing 8:30 preps, and I'll be doing a marketing plan. So at the end, you're going to see a new website I'm about to build called 8:30 Prep, which is what I'm going to send out to counselors. So say hello to Damian Metcalf, my wonderful producer. And turn on the screen. We have a special guest tonight. Again, Dr. Robinsatty, double degree from an Ivy League in science, head nerd in charge at 3R Prep, has written books. She's published on Amazon. What's the name of your book? I forgot it again upstairs. Oh man, that's it. Did you get a copy? Show. Oh, here it is. What is it called?
I got it.
All the Science You Need to Know. All right, Dr. Robinsatty has published a KDP, which calls like Kindle Direct Publishing from Amazon. So you can type in Robinsatty, all the science you need to know for ACT. I promise I'll bring one tomorrow. When we're done, I'm going to go get one. Remind me, write that down. We need like a grease board for you to write on a whiteboard.
Can you hide self-view?
Self-view. Hide self-view. I can.
And then turn your volume up all the way.
Turn my volume up all the way. And then where's my volume? Yep, volume's up all the way.
Okay.
All right, then move closer to the microphone. All right, Dr. Satty, what are we doing tonight?
Today we are going to continue our conversation about ACT science with a focus on questions about tables, charts, graphs, figures, and any other sort of descriptive word for a visual representation of data.
Visual representation of data. I like that. It's a visual representation of data. I should have my notebook out and taken notes on that one. That's pretty good. All right, how do we visually represent data?
Well, we don't actually have to know how to visually represent data. We just need to know how to read these visual information.
Excellent answer.
So last night we talked about science reading. And students may have walked away from that thinking that didn't sound very easy. It's not. Science reading is pretty tricky, but you have the tools to do it. It's the same as the reading section, just with some big words. The stuff we're doing tonight is actually easy, and you're going to walk away from this thinking that was actually easy.
Sounds good.
So, reminder from last night, ACT science is like reading in a lot of ways, it's like math in a lot of ways, and it's special in a couple of different ways too. Today we're going to talk mostly about the ways that the ACT science section is like math. There are numbers and graphs. You will often have to determine which numbers are bigger or smaller, and you usually don't need background knowledge on the content.
Big and small.
I see Phil dancing in the background.
That makes for good YouTube. I'm practicing for my TikTok.
Oh.
Big and small data.
Okay, that's what I'm still not sure what TikTok is.
TikTok is watching other people dance. So Damien and I are going to start when? Tomorrow? Saturday. We're going to solve ACT math problems and post them on TikTok. It's going to be fun. Promise me.
I could see that working. I might even have to download TikTok for that.
It's going to be, I wanted to be the nerd, but I'm calling myself the math guy. So you'll see. It rhymes with the song. I'll send it to you. It actually looks pretty good.
I would love to see that.
You have to download TikTok for it. I will send it. It'll be on.
There's more dancing.
Yeah. No, there's going to be mathing. It's going to be it's going to be on this board. All right, what are we reading? Tables, charts, and graphs and figures. We're
reading tables, graphs, and figures.
Excellent. Where do we start?
Read row and column titles.
Absolutely.
Those are your big tips. And some advice that I got from Phil himself. Very often the X and Y axis are the question and the graph is the answer. And many of the examples that I picked, that is actually the case. And then another thing is you may find yourself thinking, is it really this easy? It often is really that easy.
It really is.
The tricky part is identifying which are the questions that are really that easy. And the questions that relate to the charts, tables, graphs, figures, diagrams, etc., are the ones that are really that easy. So here's an example of a question about a table. A table is a thing with lines that represents data. It often has different columns or rows, and those columns or rows often have titles that tell you exactly what's going on. You learned how to read these in middle school, as you learned much of the stuff you need to know for the science section.
I often say
the
ACT.
This column is the amount.
I often say the ACT is like a middle school test. Are you hearing me? Are you miss?
It is, except for some of the high-end math.
Oh yeah, that's like algebra 2. That's like the beginning of algebra 2 and trig. Yeah, correct. It's mostly. How about mostly? Can I use an adjective or an adverb in that case? Damien got me on that one. I had to bite my tongue as it came out. All right, keep going, Robin.
So column title. It might be helpful to know that in a table that looks like this, very often the first column will be the equivalent of your x-axis on a graph, or your independent variable, or your input, and the second column is very often your y-axis, or your output, or your dependent variable. You don't need to know that information, but it's helpful and it can make it a lot easier. So in this particular question, based on the results of experiment 3, which are clearly this table if you're reading the whole passage, we can conclude that as the amount of NaCl added increases from 0 moles to 0.100 moles, the maximum temperature increase does what? This question is looking for a trend, and it gives you a range in which to look for that trend. So we look back at our graph, we confirm that we're looking in the right place because it says NaCl added, great, and it says maximum temperature increase. If you consider your axes, your question, your answer is going to be in the data, just like Phil likes to say. We're looking between 0 and 0.1, so we're looking from here to here in our y-axis in this column, and we see that the numbers increase only. They go up, they don't do anything interesting. This is a pretty solid example of what you'll see on this section. It doesn't get a whole lot harder than that. Every once in a while, they'll throw something crazy at you that has an outlier, where you have to sort of overlook the outlier and understand that one weird point doesn't throw off a whole trend, but that's going to be very rarely. So that's how to read a table.
Excellent. I like to call that you called that the column title, and it makes a row. I call it the information row, but I do like column title. I am actually taking notes while you're doing this. So column title I like. So you're changing the way I'm going to teach, Dr. Satty.
I was totally worth the $200,000 education. Reading from a graph looks pretty much exactly the same, except the information, rather than being written in boxes, is written on a graph. You'll see a bunch of different types of graphs. You have line graphs, you have bar graphs, you have pie charts sometimes. This isn't even middle school, this is elementary school. I think we all had that 4th grade project where we had to count the number of fruits or something and put it in a different type of graph. You know how to read a graph. But again, it'll help to know the x-axis is often your input, your y-axis is often your output, your axes are often the question, and the data are usually the answer. So in this particular question, Based on the data in figure 2, it tells us which figure to look at. Always listen to the hints that the question is giving to you. Please don't look at the wrong graph. It very often tells you exactly where to go. At which of the following pHs, if any, do enzymes A and B have the same acceleration factor? So the question says pH, acceleration factor. Your answer is going to be same. Keyword same. We want to know where A and B are the same. It's going to be where they overlap right here. Its point is at somewhere between 6 and 7. Answer choice B at pH 6.7 only. They will not ask you a question like this and give you answer choices of 6.6, 6.7, and 6.8. They don't make you work for it. These questions are easy.
These questions are really easy. And if you notice here, this is a primary example of the y-axis acceleration factor being in the question, the x-axis pH being in the question, and the data being the answer. So this is absolutely a perfect example of how the ACT gives you the questions and the answers. You didn't have to read any of the passage at all to find out where two graphs intersect means they're the same. That's it.
So then when might you find a situation where reading could help?
Ooh. Did I segue that? I didn't.
Perfect segue. We think the same way. That's why this works out.
It does. We do think a lot alike. It's actually scary how much you and I think alike. It's great though, because that makes me feel like I'm smart.
Well, thank you. So in this question, reading might help you be more sure of your answer. Phil will look at this and say, no, you have all you need in the question, answer it quickly and move on. If you're a student who tends to struggle with time management, that's your answer. Look in the question, use the cues, don't worry about the exact word, the exact meanings. If you're someone like me, I need to slow down. I'm the kind of student who finishes with 10 minutes left in a section, and I sit and stare at the page too bored out of my mind to actually review the questions like I should. So I'm better off going more slowly and more thoroughly through the questions. So for this question, according to figure 2, enzyme A has the greatest rate of reaction at a pH closest to. Well, the question says fastest rate of reaction. The graph says acceleration factor. Phil would say fast, acceleration, we want the highest point on the graph. I would say, okay, I'd like to be a little more confident because I don't quite believe the question is that easy. So I go back into the reading. I've reproduced the part of the passage that would be helpful, and it defines acceleration factor as the factor by which the enzyme increases the rate of a reaction. It means exactly what you think it does. So in fact, our fastest rate is going to be the greatest acceleration factor. And Phil was right in the first place, and I am more confident in my answer. And turns out it's as simple as that. Your answer is 5.
That's why they call the gas pedal of a car the accelerator. When you push down on it, it goes faster. Because your car always has friction and it is always slowing down. Interestingly enough, I'd like to teach the people in Pittsburgh, if they ever watch my YouTube, that if you take your foot off of the accelerator or the gas pedal, your car naturally slows down all by itself without braking. You don't have to go from gas to brake as everybody does in Pittsburgh. But that's just my beef. Next, Dr. Satty.
I'm from New Jersey. It's a whole other world of driving there.
Good or bad? Is it a good or bad world there?
More aggressive.
They're more aggressive?
More aggressive. I'd say the drivers are more skilled, but you better watch yourself. You need to fight for your position at those toll plazas.
You better position yourself at the New Jersey Turnpike.
As I will be doing probably very, very often.
Yes, you will be. What exit?
All right.
What exit are you moving to? No, sorry.
Actually moving off 78, which is an east-west road, and the exit numbers are less memorable.
All right, what do you got for me now? A figure that is not a table, but a table associated with it.
Yeah, there's a table in this question. It's a table, a regular table, but we're also looking at a figure. A figure is something that is not a table or a graph. Sometimes they sort of look like graphs. Sometimes they have axes. Sometimes they don't. Sometimes it's just a pretty picture that has some things labeled on it. It very often has a picture and some words. They're usually not too tricky to interpret, but usually the challenge is interpreting the figure as opposed to the content of the question. So in this question, it says trials 1 and 3 provide evidence that heat flow depends on which of the following factors. So if you look at trials 1 and 3, you see that everything here, remember our last column tends to be our output. So we're looking at heat flow depending on a bunch of different possible inputs. You'll notice here that all of the inputs are the same for trials 1 and 3 except configuration A and C. And the output is different, which means that the difference in configuration has some impact. Doesn't matter what the impact is here. All we need to know is how they're different. We look at configuration A, configuration C. The passage explains in a little more detail what the pictures are showing you, but you can tell just by looking. You have 2 walls. You can tell that because they're labeled walls. And in between the 2 walls, there is a block here and 2 blocks here. You can tell because they're labeled block and block. So the difference between these 2 configurations, obviously, is there's an extra block in between the 2 walls in configuration C, or different distance between the walls. So that's your answer. It's just interpreting the diagram. It's just asking you, what does the figure say? What's it telling you? And I have one more example for you. And this is an example of an extrapolation question.
Wow, favorite. Love it.
You'll always see a couple extrapolation questions. This particular example is actually not extrapolation. It's actually interpolation. Interpolation is when you have a bunch of different values and you need to guess what would go in the middle. Extrapolation is when you have a bunch of different values and you have to guess what comes next. You will see both of those all over the test. So it's useful to be comfortable with them, but it's also important to know how they ask you these questions. And they ask you in a way that is so easy. So don't worry about it. So if a trial had been done in experiment 3 with 0.060 moles of NaCl added, the maximum temperature increase of the mixture would have that would have occurred within 15 minutes would have been closest to. Once again, the axes are in your question. Your answer is on the graph. Here it's a table, and here the answer isn't exactly there, but we can figure it out pretty easily from what's there. NaCl, maximum temperature increase, and it says 0.06 moles of NaCl. 0.06 would go in between here, which means that since we have a trend of increasing temperature, with not a lot of variation in that trend, we would then expect that the value that goes in between here would be in between 34 and 50. If you want to get really specific, you would see that 0.06 is closer to 0.05 than 0.075, so you'd think the answer would be closer to 34 than 50. I'm here to tell you it doesn't matter. They're not asking for specifics. They often are only asking for which in-between interval are you looking at. We want an answer between 34 and 50, and that's the only information we need. Because if you look at the answer choices, 34 is a choice, 50 is a choice, and there's only one answer choice in between. They're never going to give you the choices of 40, 42, and 44 in a question like this.
Never.
It's always going to be obvious, and often they'll actually give you as an answer choice the interval. They'll say something like between 34 and 50 degrees Celsius.
That is often the fact.
Never more specific.
Yeah, there's a specific answer that is only one in that range, and then there's greater than 34 and less than 50, and so they will give you both. Oftentimes with extrapolation, where it ends, in this case, ends at 82, it would say greater than 82. And you're going off the chart, you're trending up, it would be greater than 82, unless, of course, this was boiling and something never gets hotter than boiling until it turns into a gas, but that's another story.
I was going to call you out on that. You caught it. Yeah, so that's why they're not asking an extrapolation question here. Something can't get hotter than boiling. But even that is more advanced science than you're going to see on the SAT.
Boiling is gases, liquids to gas, is often tested. There's a change between liquids and gases and solids. Woo, that's about what, seventh grade science as well, maybe even fourth grade.
Yes, you phase changes. Remember your phase change diagram?
Nice.
I know it's been a while. I think I'm missing part of it. Wait, phase change. There. You don't even need to know this. All you need to know is when you heat a solid, it turns into a liquid. When you heat a liquid, it turns into a gas. You don't need to know a whole lot more than that.
Oh, you
might see a question that says
sublimation, baby. You need to know sublimation. It's on one test out of the last 50 ACTs. There's sublimation, and it's not even called sublimation. It says turns from a solid into a gas. That was it.
Yep. That's what sublimation happens. Dry ice is a really good example of that. It's why it goes from solid to poofy white smoke. You will likely see a question here and there on boiling point, melting point, where they'll give you, they'll say something like a solution boils at 100 degrees Celsius, and then give you a graph, and you'll see that there's a point at 112 degrees Celsius and ask you what phase of matter it is. So you have to know, okay, above boiling point is gas, below boiling point is liquid. That's about as much detail as you're going to see on phase changes. All right, and those are all the questions that I have for you tonight.
And the
if you have any questions for me, you can reach me at robinsatty@gmail.com. I would love to hear any questions, comments, concerns, or just say, hey, I really love standardized test science. Let's chat about it.
If you really love standardized test science, this is the person to chat to, Dr. Robinsatty. She's also a very good reading and grammar and math tutor. So, are you tutoring online now, or are you just taking care of babies?
I'm doing both. I am tutoring online part-time. I do also have an almost 6-month-old at home. He's a cutie pie. But luckily he gets taken care of someone else periodically, so that I can get back to my other love, standardized test prep.
So you get to take a shower and put on big girl clothes and go on Zoom now. This is going to stay up on our website. So 5 years from now, if this is in 2020, so in 2025, if you are freaking out about the ACT science section, I'm sure robinsatty@gmail.com will still be available. This is certainly somebody who will always answer an email. She answers an email blazingly fast. This is a person that I often have to remind her that, I think I answer emails quickly, but you are amazing. So I can't wait till tomorrow. What's tomorrow? Give us a preview. What are we doing tomorrow?
Tomorrow we're talking about SAT science, which is not special enough to get its own section, but there's almost always a science-themed reading passage that includes some science vocabulary. It looks a lot like the ACT science passages, and a chart or a table or a graph that has extremely easy questions about it.
excellent job tonight. Thank you, Dr. Robinsatty, for joining us on 8:30 Prep. I'm Phil McCaffrey. Join us tomorrow night, which will be May 28th, the 40th birthday of my former teaching partner, Nathan M. Sataquis. Happy birthday, Nate. I've got another big surprise for you coming up tonight. Thank you, Dr. Satty. I will see you tomorrow night at 8:30. I'm Phil McCaffrey. We'll see you then.